Got a couple of questions that you can see we're going to work through today. I put them both here, not because I want you to do both of them right now, but because I thought, if you're going to take a screenshot of the of what's up on screen right now, I might as well just let you do it all in one hit rather than do it twice. So they're there. The top question, I'd love you to have a start at and it's our warm-up. And then we will send you into breakouts for the second question. The first one I think is sufficiently short and straightforward that you won't need that. So go ahead, take your screenshot so you've got it there and accessible, because this won't be there forever. And then have a go at the first one, and I'd highly advise you to make sure you draw a really decent diagram of reasonable size. Please use a ruler, and we will be able to have a go at that together in the next few minutes as everyone else arrives. So, top question, that's your warm-up. Secondary question, you can see that's got a bit more, it has a few more legs to it. So we will do those together once we send you into breakouts, but have a go. I hope you have at least got a decent version of this diagram drawn in your own book. It is just essential. If you couldn't tell already, we had a look at nature of proof type questions as part of our review for the trials and for the HSC last lesson. And today I want us to focus on reasoning in 3 dimensions. Obviously that comes under 3D vectors, even though for these particular questions, well for this one at least, there's not a sophisticated amount of vector thinking involved. The second question we're going to do this morning is another story, but that's why I gave this to you as the warm-up. Okay, now what we are trying to find here, what's the question? What we are after is we want to understand what is the angle between this triangle ABC. I guess you could call it the slanty one because all of the other faces that make up this tetrahedron are all on the coordinate planes. I was about to say axes. That's sneaky, isn't it? So you've got those orthogonal faces, not sides, but then you've got this ABC here, which is kind of facing us at an angle, and it's oblique, as it were. And we want to find the angle between that and the XY plane, the base, as it was described in the question, right? So being that we've got a couple of different ways in which this thing is off at a funny angle, we need to find some lengths. And at the moment, all we really know is that you've got this from the origin to A, and then from the origin to B, and the origin to C. We've been told those are equal sides, right? And I believe the length that was given to us was T, okay? So I'm going to use that as kind of my starting point. For example, if you think about this length, which is T, and I made that unintentionally fat, sorry. This length, which is also T. Because we have these coordinate axes now, there's the z-axis going upwards and the y-axis going out to the right. We know those are at right angles, so we've got a right angle triangle here, right? Even though it doesn't look like it. So that tells us we've got some lengths that we can take advantage of. So I would say, I'm going to use this purple in here, that this length, this hypotenuse here, this triangle is an isosceles right angle triangle, right? So you've got a 1, 1, root 2 relationship. So therefore, being that it's not 1 and 1, it's T and T, I can say this is root 2 times T. And I'm happy to just state that as I'm trying to sort of paddle my way through the question, right? Now, the reason why that's important is because that's off at an angle and it's going to help me understand triangle ABC. It's not the only thing that I need though. I'm also going to need to work with this AB length over here. You can see this one is going to form another side of this oblique part here. Thankfully, I already know what AB is, being that OA and OB and OC are all equal to one another. If I've got BC being root 2 times T, then I've also got AB being the same. Now I'm just going to write that AB and that distance out here, root 2 times T, because in fact that's not going to be the part that's going to be useful to me. I don't need the whole length. I want to be able to bisect that because that will help me get the angle that I need. So you can see if I bisect that, let's find the midpoint right there, and I'm going to connect it to that BC length that I had before. You can see I'm trying to form more right angle triangles here so I can get the angles that I need. That's going to be half of AB, right? So root 2 on 2 times T. Last I checked, root 2 on 2 was just another way of saying 1 on root 2. So that's that length in there. Where are we going to go next? Well, I can see sort of inside here. I've got another color here. Let me use orange to indicate that. So you can see that length there, I can find by Pythagoras, right? I've been doing this all the way through because I have a right angle triangle here. I use the same knowledge to get AB. Where's the right angle triangle hiding in here? Which plane is it on? Can you go ahead and tell me in the chat what plane is this new right angle triangle? I'll call this M since it was a midpoint. OMB, what plane is that on? Can you see it? Okay, thank you. Angad was in first, though I assume a bunch of you were also just looking and maybe typing as well. Yes, it's flat on the XY plane. So therefore, you can see, I think I will have enough use of colors here. You can see if I zoom in a little bit, right there is the right angle, okay? So I've got this side here, 1 on root 2t. I've got this side here, which is t, that's the hypotenuse. So therefore, I can use that to infer this length over here. Now, you can think about this carefully, right? You can see it's not only right angled, but it's also going to be isosceles. Can you see why it's going to be isosceles? Being that you've got this sort of isosceles triangle here, and you've gone to the midpoint, and you've got this 45-degree angle here, plus a 90, so therefore, let's see, I'm going to mark them in here. These two angles in here are both going to be 45. So in fact, even though I've got this, I could use Pythagoras to find it in this right angled triangle, I can use the same sort of proportionality trick. You've not just got right angled triangles, you've got similar triangles flying around everywhere, right? So this triangle here is the same 1, 1, root 2 triangle, right? So therefore this is 1 and this is 1, like 1 to 1, not the length 1, but ratio 1 to 1. It's going to give you the same length that you got over here. So I'm going to get 1 on root 2t up and down from O to M as well. Now from here, there is one last right angled triangle that's, that we could use if you wanted to try and find out, this angle in here. You could see it's kind of thin, so it's hard to pick it out. I'm going to need one more color here. Here we go. Woo. Hardly looks like a right angled triangle there, but that's of course because it's off at an angle. It's off at a couple of different angles, right? So you can use this triangle. You've already got, let's see here, this length here and this length here. So that's going to be opposite and adjacent, so that's going to give you tan, right? So therefore you could say, all right, I can say tan of, and I'm going to name this angle here, it's kind of stuck here in the corner, right? What color would be most appropriate? I think I should go back to green. It's this angle here, and it's kind of standing up, and it's facing towards the Z axis from M, looking at the Z axis. So therefore, the angle's name would be, whoopsie daisy, went back to green. It looks like it's going to be O, and then M, and then C. It's going to be opposite on adjacent, right? So it's going to be, the opposite side is T, and the adjacent side is going to be 1 on root 2 T. So I've got 1 on root 2 T, like so. So I'm going to have tan of OMC being, have a look here, my T's will cancel. I've got 1 over 1 on root 2, so that looks to me like root 2. And if you go ahead and pop in tan inverse of root 2, what do you find? What do you get? And I want to go ahead and post in the chat what they've already rounded. Yeah, fantastic. Thank you, Varan. Emmanuel also got in there, I should put an approximately equal sign, shouldn't I? Approximately equals 55 degrees. So that's kind of nice. And you can see the reason that we went through there. If the question was, as the original question was actually, I just slightly adapted it. If the question was to prove, for instance, that it was roughly equal to 55, or an equal result that you might have been asked to prove is that that angle, I'll just call it theta, is equal to tan inverse of root 2. Or you might even ask to prove that it was cos inverse of 1 on root 3. You'd need the hypotenuse in there, the one that I drew here in orange. We would need to provide that reasoning a little more clearly. I haven't told you rather how many marks would be assigned to this, but you might see something like 2 or 3 marks that would have to be attached to the reasoning, that we would have to say things like, oh, okay, this is a right angled triangle, why is that? OMB is a right angled triangle, why is that? How do I know that it's going to be isosceles? Things like that are really important to reason through, but I wanted you to just get your mind warmed up again, as I said before.